Hello everyone, welcome to lecture 14. In this lecture we are going to understand more about frying. Each one of us has fried something. Maybe you fried an egg, maybe you fried some potato chips, or maybe you fried meat. Frying is one of the key activities involved in cooking of fats and oils. Frying is carried out at a temperature of 180 degrees Celsius, and this process exposes oils to heat, air, and moisture. During frying, oils undergo oxidation, polymerization, and hydrolysis. Fried food retains a portion of degraded oil, which impacts health and quality, and that is why it is not recommended to recycle used oil. The behavior of frying oils. 1. Volatiles. Volatiles are formed from oxidation of hydroperoxides, which include aldehydes, ketones, hydrocarbons, and esters. And this leads to a balance between formation and loss through evaporation. We also have the non-polymeric polar compounds during frying, which are formed via alkoxy radicals, and it involves moderate volatility and also contributes to oil degradation. We have the dimeric and polymeric compounds resulting from free radical polymerization and also increases oil viscosity. Free fatty acids also arise from the hydrolysis of triacyl glycerols due to heat and water, and also increase acidity and reduce oil quality. Refining oils improves oil purity and shelf life. Hydrogenation stabilizes and modifies oil structure. Intensification customizes texture and melting behavior, and proper frying management is very crucial to avoid harmful degradation and ensure product quality. Like we said earlier on, frying involves immersion in hot oil, and it causes both chemical and physical changes in food and oil, and impacts the quality of frying oil, which also leads to impacting the flavor, the nutrition, and the safety of this oil and the products formed. During frying, water is released from the food into the oil, forming steam, and this creates a steam distillation effect. Volatile oxidation occurs, and the volatile oxidation products are swept away. And also, it causes agitation of the oil and accelerates the process of hydrolysis, reducing oxygen contact, leading to slow oxidation. Endogenous lipids may also leach into the oil during frying, and this may alter the oxidative stability. Oil absorption by food varies by the food type and also leads to oil depletion, which will need for oil replenishment. Oil darkening accelerates with food presence. This is very practical when you're frying a dark colored food item. You find that at the end of your frying process, the oil color changes according to the color of that food product that you have fried. The chemical and physical changes. During frying, we have noted that not all changes are undesirable. Some of these changes are good because they may increase the flavor or improve the flavor of the food, the texture, and appearance. Uncontrolled decomposition damages the sensory and nutritional quality of these foods. And influencing factors here is the oil and the food composition, the frying temperature and time, and also the metal contaminants involved. Frying oil quality tests. Our goal here is to monitor the thermal and oxidative degradation, and the common methods applied are viscosity, FFA or the free fatty acids, the smoke point, forming, polymer formation, and sensory analysis. The specific oil quality tests that can be carried out, petroleum ether insolubles. Here, the oil is detected if 0.7% insolubles and smoke point is less than 170 degrees Celsius, or greater than 1% regardless of the smoke point. Polar compounds. can be fractionated via silica gel column, and 27% of polar content leads to unusable oil. If you find that there is 27% polar content, it's advisable for you not to reuse this oil. Dimer esters can be measured using gas chromatography, and they indicate the level of thermal decomposition. There are some quick tests and sensors that can also be applied. For example, the food oil sensor that measures the dielectric constant also can measure the level of the polarity. Increase the polarity leads to increased degradation, and hence advised not to use the oil again. Quick and non-invasive method. This is a very quick method that you can conduct at your convenience. What are the good manufacturing properties involving fats and oils? To maintain the quality of oil, one, you have to choose the stable, high quality oil, choose the well-designated equipment, and also fry at optimal temperatures. You have to filter the oil regularly and periodically shut down and clean the equipment, and also replace the oil as needed. Avoid overusing the oil. Monitor antioxidant levels. You also have to train the personnel involved and also conduct frequent oil testing. The key summary from this class is that frying causes complex interactions between oil and food, and proper management is important for product quality, safety, and operational efficiency. Regular testing and adherence to best practices ensure optimal frying performance. Thank you, and we meet again in the next class. And this marks the end of our lectures for lipids involving introduction to food chemistry. In our next class, we shall be able to now understand about proteins and the protein food chemistry. Thank you.